Here's another problem of a moment of a force about a line. So we have this bracket here. It acts at point C. We're given the Cartesian vector of that force. It is anchored at a point at the origin point. And the question now is, what is the magnitude of the moment of the force about the x-axis? Or see our x-axis right here. So I'm not really sure why we know that it's anchored at the origin. In the end, that has no impact on us. But what do we have to do? Well, again, we have to find the unit vector of the line. In our case, the line is the x-axis. Right, so coming out, this will be our line. So that's pretty simple to get our unit vector, right? So if we want to do our unit vector in the x direction, is of course just 1i plus 0j plus 0k. That is pretty easy. Now the other thing that we need is we need to have a vector that points from anywhere on our line to our force. So let's think. So we could of course do the origin all the way over here, but the easiest one is going to be just going from A to C. Right, that would be our RCA. So let's find RCA. So we could again go through and do, well, where is A, where is C, but we can also just, it's pretty simple geometry, so we can just find our RCA directly. RCA is equal to what? We're not going anywhere in the x direction. We are going 0.5 in the y direction. So let's go 0i. We're going the positive y direction for 0.5, so 0.5 j, and then we go 0.3 downwards, so 0 and minus 0.3 k, and this is all meters. All right, so with that we have our RCA, so let's give ourselves a little space, and then we can find our m around the x-axis, so let's call it mx. So that's of course ux, if you write out ux dotted with the cross product of RCA with P. No, in this case it's F, not P. Still on the last problem, it seems. If we write that out, we get, what is our unit vector? Was 1, 0, 0. Our position vector was 0, 0.5 minus 0.3. And then our force, we can just see it up there, 300 minus 200 and 150. 1, 0, 0, 0.5, 300 minus 200, and that was kilonewton times meters. All right, let's see what we get. We get the first one would be 0.5 times 150 times 1. So that would be, and let's write it out. Not in red. Let's see, where's black? So it would be 1 times 0 times 0.5 times 150. Next one is 0. This one is 0. This one is 0. Then we get minus, because we're upward. Might as well draw the line though. Right there. So minus 200 times minus 0.3 times 1, and then another 0. So only 2 components. And if we plug those numbers in, we get 15 kilonewton meters. And that would be the magnitude of our force F about the about the x-axis.